Okay, so now we're going to go ahead and upload the code for our car. So I'm going to connect the USB cable and upload the code. Okay, so once that's uploaded, I'm going to open up the serial monitor here. And initially, the car should be in a stopped mode. What we need to do is a couple of things. First, we'll need to connect. Remember that coming from the VCC on the motor driver, we need to connect that to the positive of our power source, our 6-volt battery. So I'll connect that. When you do, you'll see a red light turn on the motor driver circuit. That means it's ready to go. The other thing that we'd need to turn on is the 9-volt battery. So I'm going to go ahead and turn that on. And I'll just disconnect this Bluetooth module here so you can see. As you can see, the module is blinking. That means it's not paired to a device. So it's not paired to anything. And now we're going to actually pair it to the app. So I'm going to open the app on my phone. Alright, so here's the app itself. As you can see, first I have to connect a device. So I'm going to hit connect a device. And you'll see that HCO6. When you open the app, you can scan for devices. It should pull up a list of Bluetooth devices. So that's the device we want to connect to. So I'm going to click on that. It's trying to connect. Oop, it said it was unable. I'll try again. Right, connection successful. And as you notice, once it's connected, you'll see that the Bluetooth module here, it stopped blinking. So that means it's now paired. Okay. So once that's the case, let's go and test out our circuit. So I can actually disconnect the Arduino, and since it's being powered remotely from our 9-volt battery, now it's mobile. So the first thing on the app, you'll notice there's an actual activate button. So no matter how we move the phone, it's not going to actually drive the vehicle, right? You have to tap on that activate to get things started. So let's first test out the direction of the motor spins to make sure everything is okay. So I'm going to raise my vehicle off the actual table because it's going to drive off, right? And now I'm going to click on that activate. So I'm tilting the phone forward actually. So you see the forward arrow on the app. So it's driving forward. That looks like it's working. Backward, I'm tilting it back. Backward looks fine. And left. What I notice is left and right are mixed up. So if I do right, all right, left and right seem to be mixed up. So let me stop it. I'll just click on that to deactivate it. All right, and now, no matter how I move my phone, it's not going to do anything. And let's address that problem. Let's quickly fix it. Since everything is wired up, the easiest thing to do is to actually fix that in code as opposed to trying to change the circuitry. It's already wired up. So we noticed that left and right was switched. So the easiest thing we should do is when we're processing the commands, instead of if command is to turn left, let's change this to turn right and turn left. And remember, this would happen simply because of how you wire up the motor driver and those pins. And if you get a pin off, that it might switch the directions on you, but it's easier to tweak it in the code here rather than mess with the circuitry after it's wired up. Just make things a little bit cleaner. So I'm going to go ahead and connect my Arduino. And I'm going to go and upload the code again. Alright, so now that problem should be addressed. So the moment of truth, let's go take this for a test drive. Okay, so now we're going to actually take our car for a test drive. This is the moment of truth to see if all our hard work paid off. So here's the app, and of course we want to make sure that we connect the actual device. Click connect device, and you want to make sure that you connect to your device. So just remember that. If you look at the car now, the Bluetooth module itself is lit red, it's not blinking, so we're connected. And remember, to actually drive, you have to check the activate switch. So right now I can move this around, it's not going to do anything, but I'm going to hit activate, and then if I tilt the phone forward, the car is going to drive forward. So let's go, let's check this out. Alright, so there it goes forward, back, turn it left, turn it right. Alright, so there you have it, our car is working. We are actually using an Android app to communicate via Bluetooth to drive our car. So here we go, forward, backward, left, right. And we're just using the accelerometer on the phone, and it works pretty good. So there you have it. Awesome project. Using the power of Arduino and using a inexpensive Bluetooth module, we're able to create a remote control car and use accelerometer motions on our phone to determine the direction of the car. So really cool, guys. I hope you guys are able to successfully complete this project and get it to work. But really cool. Let's give it a drive again. Here we go. Forward, backward, left, turn right, turn left, forward, backward. Alright, works pretty good. As you can see, it's very responsive, and as soon as very responsive to the accelerometer motions on the phone, so it works really well. Hope you guys were able to get yours to work equally as well, and hope you're having fun with your project. Let's dive into the code for our Bluetooth car controller. So essentially, at the top of our program, we've seen this before where we define the motor left and motor right pins. Next, we have the global variables for the command that is currently being issued and the PWM speed. In our setup, we initialize the input pull-up resistor on our receive pin, which is pin 0. We set the speed of the serial communications. Typically for our Bluetooth module, this is 9600. Then we set up our motors as output, so the motor pins are set as output. And initially we turn off our motor, so we call the motor stop function. This is the exact same function as we had seen in our motor driver circuit. In our loop function, this is where we listen to see if any information has come in via our Bluetooth module. So basically, if serial.available is greater than 0, that means that some information has come in. We do a serial.read and store what was sent in command. If command is 1, we drive forward, else if command is 2, we drive backward. If command is 3, we turn right, 4, turn left, and if command is 0, we stop. If we get a command that we don't recognize, we stop the vehicle. Very, very simple loop program, and we simply wait and listen for any inputs that come in and act on those inputs to drive our vehicle accordingly. We should also note that those 1, 2, 3, 4, and 0 values are being sent from our Android app. Basically, depending on accelerometer motions for a left, if that's detected, the Android app sends the instruction to turn left. It actually sends a number 4 to the Bluetooth module, and once that's received, the logic takes over and it knows that it has to turn left. Very simple operation. These functions, motor stop, turn right, turn left, and drive forward and backward, are all the same functions that existed in our previous motor driver circuit. So based on the actual position of the mobile device, when accelerometer measurements are taken, corresponding values to move backward, forward, left, and right are sent to the Bluetooth module, which in turn are translated to the Arduino, which in turn sends that onto the Arduino so we can process which direction that the car needs to drive. There's not a whole lot of complexity involved here. It's a very simple and straightforward operation.